All right, continuing with the last problem, we developed the following recursion, which we can check from the original constants right here. A2 does equal the negative of A0, which if we replace n with 0 gives us exactly that statement. Now we're going to solve for the even and the odd coefficients separately, and the reason is because the indices differ by 2, which means when n is even, both of these are even. When n is odd, both of these are odd. So if one at a time we replace n with 0, we get the following. If we replace n with 2, we get A4 is negative 1/3 A2, but then substituting, I get in terms of A0. Continuing, A6 is this, substituting back in, and so on. So we can write all of the coefficients as constant multiples of A0. Now for the odd coefficients, we do exactly the same thing. If I replace n with 1, I get A3 equals negative a half A1, and then continuing, A5, and then substituting back in, and so on. So I can write all of the odd coefficients as constant multiples of A1 also. Now, using the coefficients we've just found and putting them back into the solution, A0, there's my A2x squared, there's my A4x to the fourth, and so on, I find that the even part of the solutions, when I factor out the A0, gives me this. Now notice A0 is an arbitrary constant. This serves the purpose of our C's that we normally have. So if I had initial conditions, I would find A0. Same thing now with the odd coefficients. There's the x, there was the A3, there was the A5, the A7, and so on. And then I write the odds this way. So my final answer is essentially, in this case, y1 plus y2. Now, some of you may recognize a pattern with the coefficients. For example, there's an underlying factorial pattern with this one. With this one, 1, 1/3, 1/3 times a fifth, 1/3 a fifth, 1/7, and so on. There's an odd pattern in the denominator. If you recognize a pattern, it is always encouraged to see if you can come up with a general term. If you don't see a pattern, then you're kind of forced to leave it in this somewhat incomplete form. But this is acceptable for now because we've answered the problem completely.